This project has a lot of people that worked on it, so I listed them out there. It's me, Howard, Natalia from Mathematica, that some of you may know, who's also a former student of Steve's, Himani, Amma, and Dan, who are the outer ones from MDRC, and Amma from Mathematica. And then I think Steve at least has contributed a lot of ideas as well, although he's not officially one of the authors of this work. But so just some of the things I'm going to do will reiterate a lot of what Howard said this morning, but the main thing, as Sean said, will be providing some empirical evidence about how much effects vary across sites. And the general idea here is that there's been this big increase in RCTs over the last couple decades, which is nice because it gives us an unbiased estimate of the overall average of treatment effect. But with this has become increased interest and appreciation of how much effects vary. And as Howard alluded, you can think of this in lots of different ways, and I think Sean actually as well. You can imagine trying to understand how much effects vary across individuals, but as Howard pointed out, you really can't know that for sure without making some assumptions that maybe you're not comfortable with. But one thing that we can do relatively well, we think, is to estimate how much effects vary across sites, making at least much more minor assumptions, I think. And in this case, by sites, we usually mean schools, but in some cases it's welfare centers. In an example of the group that I was talking to before, it could be prisons. There's lots of different things you can imagine being sites, but the general idea is just how much do the site average impacts, how much do they vary across sites. And so that's what we do, and we do this with 15 pretty large-scale multi-site RCTs, all of which use individual random assignment. So that's sort of the basic premise. Just an outline of where we'll be heading the next hour. First is just to remind people, in case it's not obvious, why effects tend to vary across sites. We're not actually going to push to that point with the results that we share of trying to really understand the reasons why, because we're starting off, again, as Howard kind of alluded to, from the most basic, just trying to quantify it, how much of this stuff is out there. But you can imagine really wanting to know why the effects vary. And then also, I'll just try to get you guys to join for a minute by trying to get you to explain to me why we should care in the first place. Then we'll just review what Howard defined as the cross-site distribution of effects. I'll just show that plot again, and we'll move on. Then I'm going to show you the data that we use to estimate how much effects varied across sites from these 15 RCTs, so you at least have a little bit of background of what the studies were that we were looking at. I'll review the estimation model, and then I'll share some results, and then probably we'll spend half the time discussing the implications for these findings. OK, so one of the readings that you had, which maybe you did or did not do, so I'll summarize it, assuming that you probably didn't read them all, was the Weiss, well, that's what I would have done if I were you, was the Weiss, Bloom, and Brock paper, where we tried to just make things simple when people are thinking about why it is that effects vary across sites. And we said, if you think of treatment effects starting from the point of service forward, you can pretty simply categorize most of the reasons, or probably all the reasons why effects vary based on these 3 C's: the treatment contrast, the client characteristics, and the program context. And the treatment contrast is the difference not in the potential outcomes that we talked about, which would be more about the program effects, but it's the differences in the sort of services or experiences that you get when you're offered the treatment or in the program group, versus the counterfactual services that you would have experienced, which are proxied by the control group if you're not offered those services. So that could vary across individuals, and that could cause impact variation across individuals. It could vary across sites, causing variation in impacts across sites, and so forth. Client characteristics, this one I think is the one that people tend to think of, I think, really often, which is oftentimes accomplished through subgroup analyses in studies. So this is the effects vary by gender or race or your prior level of risk. Maybe some pretest is we're trying to see if the effects vary across individuals, again, or sites based on these client characteristics. And the third possibility is the program context. And my favorite example of this actually comes from the Welfare-to-Work studies, where if you think of the local labor market as being sort of a contextual factor, the effects of those 59 welfare programs, they actually vary depending on what the unemployment rates were across those sites. And you probably remember, Howard, which way it went. But I think the impacts were bigger if the unemployment rate was lower. Does that sound right? OK, yeah. Yeah, OK. So if you didn't hear that, there were theoretical arguments why you might think it would work either way. And in fact, I think oftentimes that's the case, that you can imagine sort of theoretical arguments as to why it is that those that are most at risk will benefit most from a program, or those that are least at risk, or where local unemployment rates are lowest or highest, will benefit the most. But they, at least in that study, were able to estimate. They have those 59 impact estimates across all sites, and they looked and they saw actually those sites where the labor market had the lowest unemployment rates where the impacts were the largest. So those are sort of the 3 main reasons. And at least when I think of planning a study and trying to set up hypotheses I might want to test, I oftentimes like to walk through each of these and just say, all right, what are some a priori hypotheses I have about why the effects might vary across clients, and I just sort of like think of client characteristics and then walk through, do we have some real good rationale? Ideally, you might even have some literature, some empirical estimates from past studies where you've seen this. That would be good to then kind of confirm your hypotheses, or it might just be theoretical. And so I just kind of walk through them all and try to think about it, what's possible. If you read the paper, the treatment contrast kind of is a result of many things that precede it, whether it be the fact that the programs that were planned in the first place might vary. So if you're looking at cross-site variation, the planned set of services that would be offered to program group members could vary across sites, which then will probably lead to the program group members receiving different services at those different sites, and that could explain it. So there's a lot of stuff that leads up to the treatment contrast that is worth thinking about. But I think if you think from the point of service forward that these three kind of sources are the main ones as to why you might expect effects to vary, and again, both across individuals and then at the site level, why they might vary across sites. And I bring this up, one, because I feel like hopefully that paper is just helpful to help conceptualize this, but also towards the end of this talk, I'll present these results of how much we saw effects varying, and then we'll kind of bring it back to these 3 points and see, can we actually anticipate when we might expect a lot or a little cross-site impact variation, and I'm going to try to use these as a framework to think about it. So, all right, so audience participation. Why do we care about this stuff in the first place? And I think there's been hints of this throughout the day, but I just want to make sure it's sort of solid in all of our minds. So can you just think of some reasons, and you can look at the results, but I say substantive implications, like that doesn't mean anything. The planning stuff you might have got from Howard's talk, but what are some substantive implications for why we'd care about cross-site impact variation? And I learned I went to an ed school and they taught me like you should wait like a minimum of 10 seconds, which is super uncomfortable for silence. But if no one raises their hand, like you should wait. So I'm going to wait, and like I will wait you out. So I saw a hand in the back. Okay.
It helps you better understand the question why, like why it works
Yeah. Totally. And I think a lot of what Sean will talk about later for sure is effects vary across sites. You might then be able to predict it in some way, and that might help you to understand like mechanisms. Yeah, for sure. Yep, great. Yeah, so welfare to work, probably if the labor market is not so good, maybe that's the kind of place you want to actually do a welfare to work program. If it turns out that you actually model that impact variation that Howard showed on the screen, and it turned out that the effects were negative when the labor market rates were actually really high, you might say, wow, let's really not use this kind of a program there, but yes, let's use it in low unemployment rate labor markets. Anything else people can think of? If not, now that I got two, I'll give away the other ones that we've thought through or thought about a bit. One of which is just thinking about generalizability. So, and this requires some assumptions probably, but if a program has really consistent effects across all the sites in a particular study, you might start to feel, well, first you'd feel really good if you had a random sample of sites and the effects didn't vary at all, that the effects probably don't vary much in general, and then you feel like these are really generalizable results, and I can actually just take that mean impact estimate and feel great about thinking about that as being what the effect would be in some new set of sites that didn't participate in the study, but because of, if it was random sampling, you'd feel really good. But I'd say even in the case where you don't have random sampling of sites, you still might feel like if the effects are consistent, that it's more likely that when I go to new sites that they're going to also have the similar results as I saw in my study. If it turns out that selection into your study is highly related to how effective the treatment is, then that won't be perfectly true. But probably, in general, you might feel a little better about the likelihood of your results generalizing to sites outside of your study if you see homogeneous effects within the study.
Yeah, I was just also thinking if there's an important cost implication. So if you're working with a limited budget and you can only implement them over Head Start or some program in certain places, you want to know under which conditions it's most effective so that you can.
Yeah, I like that, like maximizing efficiency. So if I know the places that even if it has positive effects everywhere, but it's more positive in some places and I've got limited resources, let's do it where it's the most effective. Yeah. I think also Howard mentioned earlier today, like if you're a policymaker making a decision, you might just want to know how risky of a decision this is. Are there going to be places that I'm actually harming people or not? So you can think of it that way as well. But then the other reasons, those are sort of like substantive reasons, at least I think. Then there's this issue of when you're planning a study, and this is at least one of the things that we'll work through here, which is, if you're designing your study and and you're doing your power calculations and you want to make sure that you have a minimum detectable effect that you feel like is at the right level, you need to plug in a value of tau, which is how much the effects vary across sites. So currently, at least as far as I know of, there's like almost no empirical information about what you should plug in there. So Howard plugged in, I think, 0.15 for his tau, and that was in standardized. But like, I mean, he used that in part because he knows what the results are from here. But before this, you just had no idea what to plug in there, which similarly to other types of trials. So if you've read the literature on like cluster randomized trials, you need an estimate of the interclass correlation. And originally when people first did those, they were like, I don't know what to plug in. And then Howard and Larry Hedges and others provided lots of empirical evidence so that now when you're planning a cluster randomized trial, you kind of know what values are reasonable to plug in there or not. And similarly, we hope that the results we share can inform, if you're doing a multi-site trial, what should you plug in for tau. All right. So this is reiterating stuff that Howard already showed, but if we just by definition, we're going to say that B sub j is the true average treatment effect at site j, then a parameter of interest for the cross-site distribution of effects, you can call it beta, which is the sort of overall average impact, where you're weighting each site equally. So if it's just sort of this is just a regular average formula, but I'm saying each site is going to count equally towards that beta. The variance formula, or the standard deviation formula, is similar. Like these things should look similar, where now you've just got the sum of the squared deviations from the mean divided by j, the square root of that. So those are going to be like our two parameters of interest of this cross-site distribution of impacts. And then here's the picture that Howard showed before as well. So this should now all be fairly familiar. Any questions so far? No, this is easy. Good. All right. So the data. These are the different studies that we managed to get data from in order to estimate those two parameters of interest. We selected them based on a bunch of different criteria. One was they had to all be multi-site trials because we wanted to be able to estimate impact separately at each of the different sites. They also had to have individual random assignment because that would then allow us to, again, get impact estimates within each, separately for every single site that would be unbiased. You could have had, I guess, like some cluster random assignment if they like randomized teachers within schools, for example, but all of these at least had some part of them that were individual random assignment, which leads to also slightly more precise estimates of the impacts at every individual site, which means that beta and that tau hopefully are a little more precise because of that. They're also like some of the largest studies that we could just find in general. So we wanted as many, because of the formulas that Howard showed, we wanted as many sites as possible and as many people per site as possible. So most of them, I think they range in size from the smallest having 9 sites to the biggest being Head Start, which I think has something like 300 sites, or at least hundreds of sites. And they range in sample size from around 1,500 people, mostly students, to 59,000. Well, that's the WelfaretoWork one, so pretty large scale. And again, this is so that we'd have fairly precise estimates of beta and tau. And we also were interested in doing this across the spectrum, so from early childhood all the way through post-secondary and then even into the labor market. So we have sort of like hopefully a nice variety of different types of studies in here. I'm just going to highlight a couple of the programs because I'm going to show that I'll try to highlight the results too. In the paper, we have a description of every single one of these, the programs, the target population, what the control condition was, how the experiment worked, how many random assignment blocks there were, how many sites, so forth. But just to highlight a few that I'll then highlight their results. So one of them was this after-school program where if you were in the program group, you got the Success for All curriculum. Is this like familiar to anyone here? Maybe the people who focus on education. If you're not familiar, it's a very structured curriculum. It has a particular pedagogical approach. What you do if you're an instructor in these Success for All kind of classrooms is at least considered relatively highly prescribed. But it was after school, so they sort of modified the normal Success for All program, so you experience a 45-minute block to boost your reading scores. If you were in the control group in this study, you were served at the same center. They already had after-school programs, but you didn't use this super structured program. Instead, you just went to the regular kind of business as usual services where they kind of worked with you on your homework or whatever else, but there wasn't quite as much formal education, and certainly it wasn't prescribed exactly what experiences you'd get across sites. And this happened in grades 2 to 5. So another school that Mathematica did, another study that Mathematica did is a charter medical study. For those of you that are familiar with charter schools, these are public schools that are released from certain state and district regulations, including things like how you hire your staff, the curriculum, budget decisions, so forth. So they're given a little more flexibility, but they're still held accountable for their student outcomes in terms of like No Child Left Behind kind of accountability policy. Interestingly, in this study, it's not like of KIPP charter schools. It's not like one charter school model. It's charter schools that were oversubscribed across the nation, and they're sort of looking at how much overall did the what was the overall effectiveness of those people that were randomized into getting to go to the charter schools. And again, these were charter middle schools, so it's a middle school grade level. Two more. that I'm just going to go into a little more detail on, which is career academies. This is a high school program that's sort of a school within a school. You're enrolled in a kind of a learning community where the curriculum is supposed to be integrated across subject areas, but then also it's supposed to be integrated in terms of the kind of career you're interested in. So they try to make sure that some of the material that you're covering in class relates to your potential interest in careers. And on top of that, local employers were actually involved, and the students were involved in work-based learning programs. And this was mostly 9th and 10th graders, although it carried them throughout the school. In the control condition in this, you were actually at the same location. So you're at the same school. You just weren't enrolled in these career academies. You were in their sort of big business as usual high school programs. And then the Welfare-to-Work program, I won't say anything about that because Howard already described a little bit about that. But large-scale study, yeah. OK. So our estimation model, this should look sort of familiar. I've written it a little bit differently than Howard wrote it, but this is the 2-level model where we have fixed intercepts and random coefficients. Some things that I'll highlight. I think Howard actually wrote this down here, but it doesn't really matter. These are our fixed random assignment block indicators. In most of those studies that I listed there, the random assignment occurred within random assignment blocks that are not the sites. It's actually like a lower level. So in most of the education programs, it occurred within a grade within a school. Or it occurred across cohorts within a school, which I think is one of the reasons that Howard's example that you all worked through had that. So we include fixed random assignment block indicators, in part to account for the fact that the treatment assignment ratio was sometimes different across random assignment blocks, even within sites. So if the sites are schools and the grades are blocks within the schools, sometimes the random assignment ratio is different across grades within schools. So you kind of have to account for that. So that's why we have the fixed random assignment blocks. Here's the treatment indicator. Again, like before, it's allowed to vary randomly across sites. So beta is our estimate of it's going to be our treatment effect for the average site, where it's allowed to vary randomly across sites. And it has, if you look down here, it has an estimate of the cross-site standard deviation will be tau. I added covariates. I don't think Howard had this in his model. We put in fixed covariates at level 1. We don't have anything we're not trying to predict how much effects vary across sites. We're just trying to quantify it. So these are here just to improve the precision of our impact estimates. Questions? But yeah, please.
So when you say, in this case, for like the randomization block as a classroom, when you say sites, do you actually mean school sites, or do you mean now classrooms?
Nope, school sites, yep. And you could, so I feel like when people I was in one of the groups and we were talking about how you would write out a model where you have blocks within what we're calling sites. And sites, we just mean physical locations. It's schools, welfare centers, whatever. We've treated them as, we're only trying to quantify how much effects vary across those physical locations, across those schools. You could imagine another version of this model where you're actually trying to quantify the total amount of variation across random assignment blocks, which would include both how much impacts varied across your schools, but also within schools, but across grades or across cohorts in studies that have multiple years. We're not doing that. You could, but we. I have a harder time thinking about. I can conceptualize why it is that sites are like a random sample from a population of sites. So like you only do a study of 50 schools, but you're thinking of the population of schools. I have a hard time thinking about that with grades, so I kind of like them to be fixed. I have a hard time thinking of grades 2, 3, and 4 as being like a random sample from a population of possible grades. Same thing with cohorts. So I'm more comfortable with this, but I know that others are okay with doing. Yeah. All right. What else is worth saying? Oh, and like Howard talked about before, this is our little way of symbolizing that we're allowing the level 1 residual variance to be different if you're in the treatment group versus if you're in the control group. So similar to the model that Howard described earlier. OK. Results. So these will be select. So we looked at the results across those 15 different studies for what we deemed as sort of like the primary outcome. So many of these studies, when we got access to the original data sets, we read the original reports. They looked at lots of outcomes. We tried to do our best job of determining what they thought were kind of the main ones. I'm going to present, just because it fits on a page, one outcome per study. But in the paper that we sent around, you can see we look at quite a few other ones. So here they all are. A column of the betas, a column of the estimates of tau. I tried to make the decimal points line up so you can read it more easily. Stars, if they were statistically significant, I think 1 star was 0.10, 2 stars 0.05, and 3 stars 0.10 or 0.01. And you can see there's different types of effects that we see. In terms of the overall average effect, nothing seems to be harmful overall on average. I guess here's one negative one, but it's not significant, another one. But most of them seem to be sort of positive-ish. Here's our taus, how much effects vary. We have some examples where it's estimated actually to be 0, some where it seems to be pretty large. Sorry, I should say, I tell you like kind of outcome we're talking about over here. So the ones with ES, they're in effect size units, is how we're talking about. Some of them down here, I don't like to present in effect size units because they're things that have meaning in their natural units. So like I hate the idea of changing my average yearly earnings impact in welfare to work into effect sizes because hopefully dollars make more sense to most normal humans than effect sizes do. So I think it's almost like there's a cutoff here that it seems like most studies in the older ages or grades, the outcomes tend to be in natural units, whereas they're in effect sizes up here. So there's sort of different distributions we see, and I'm going to just sort of walk through a couple. So here's one where there's like basically the overall average effect seems to be close to 0 and very little impact variation. You got the kind. Yes. Yes. Yeah. Here's one kind of slightly harmful on average, the charter middle schools, but not significant. So maybe it's basically around 0-ish normally, but quite a bit of variation in impacts. Here's one. This is the dream. This is like the rare dream, I think. Positive, statistically significant effects. No clear evidence that the effects vary across sites. Very exciting. Not. Yeah, no, I'm not. So this study, so it's like fun to present because it makes it sound like these all seem to exist. But I know this study. Yeah. But if you know the truth, there was 9 sites in this study and 1,500 people. And so one thing we haven't done yet, but as our next step in this project, we haven't added confidence intervals to these. And my guess is this estimate is 0, but the confidence interval, because there's not a lot of sites. And remember, this is the tau where, am I remembering correctly? You wanted to have, oh no, actually, you wanted to have few sites but very large sites. So in some senses, this might not be terrible in terms of precision. This is back to Howard's slides. If you remember, for beta, you want to have many sites and they can be small, but for tau, you want to have few sites and they can be larger, actually. So this, but it's only 1,509 sites, so it's probably not super precise. When we add confidence intervals, I suspect all of a sudden you won't feel great about characterizing this as clearly. Yeah, I think that's going to be right. We're about to add that to this work. And then here is another example where there's both positive effects, and by the way, if anyone picks up on this, these results will look different than what Howard presented because we've done them in different years. Like the earnings are in $2015 one time and something else somewhere. And I think he did cumulative earnings across 2 years, and I'm doing average. But positive effects and a lot of variation. So you kind of got like the spectrum of different types of distributions. All right, that's what I wanted to say about this. Any other questions about these findings? You should look across all the tables because I feel like I've cherry-picked some of them a little bit. So we made the same kind of graphs to illustrate this point that Howard showed earlier. So these are plots of the constrained empirical Bayes estimates, the ones where you kind of fix the distribution to have a standard deviation that's equal to tau. So it's not sort of like if you just took the treatment minus the control and then you get the way too wide distribution like Howard was talking about because it's all estimation error. But it's not the empirical Bayes that kind of overshrink, it's the sort of just right ones. So here's an example of the consistent, this is the after-school reading program where basically there's no effect anywhere, it seems like. This one has 25 sites and a pretty good number of people per site. So maybe this one you feel a little better about saying. It really doesn't seem to make a difference anywhere. Yeah, I think so. Although, well, the number of people is not so, well, I think when we start making the confidence intervals, what we're going to find is that tau is never estimated that precisely. Yeah, because we've tried it on the welfare to work, which is like the dream scenario. It's 59 sites and 59,000 people, and still it's a pretty decent size. Yeah, but again, that doesn't matter as much for tau, right? So. Yeah, maybe that's sort of like what welfare to work. Well, that doesn't, that wouldn't be precise?
Yeah, 2 times the variance divided by n.
Where here n is j, right? But yeah. Yeah. So so maybe we're never, I don't know. It seems like we're going to never have super precise taus, or it's going to be pretty rare. Same kind of graph, but for the charter study. I mean, for those that are interested in charter schools, this is like totally interesting, I think, right? Like, they seem to on average be not be making much of a difference, but they vary a lot. And this just, it has to beg the question of, what were these guys doing and what were those guys doing? And like I said, this was just a whole bunch of, this was like Mathematica going out and searching for charter schools that were oversubscribed. It wasn't all KIPP or Red Green Dot, whatever, I don't know charter organization names, uncommon schools. They're just a variety of different ones. But maybe it turns out that all the KIPP ones are up here and that all the Green Dot ones are down. Like, it'd be nice to kind of to know that. And I think people have looked into at least some of the programmatic features of these programs and seen whether or not they actually predict where the effects are largest and smallest. And that's definitely a nice next step that one should want to take. But there's a lot of variation. No excuses. Yeah.
Yeah, they have strong, a lot of feedback to those features. There's 5 characteristics, but yeah, exactly. That's the characteristics of the program, but they don't, I don't think they know what the counterfacts look like, how many tests were each,
Yeah.
how much feedback teachers were getting in the counterfactual school.
Yeah, no, I agree. Well, that'll be part of our nascent theory. Exactly. Yeah, yeah. You only know the treatment part of it, and especially in a study like this, like if you imagine how this actually happens. So, people subscribe to go to this particular charter school, but it's not like they all go to the same other school. Like, they're just scattered about in a whole bunch of different other schools. So, as a data collection activity, thinking about how you'd even learn. So you could go to this had 34 charters. You could go to them and collect information about the program services that they offer. And you might even be able to do classroom observation or something. But to get the information.
Another comment. So this guy, Chris Walters at Berkeley, and his students work with Josh and MIT, they're really developing pictures of the value added of all of the schools that you build on it.
Nice.
And what they're doing is they're using the charter school data to validate the value added and even correct the value added statistics.
Huh.
So they're sort of able to estimate. Okay, so Jonah Deutsch, you write down a model for the effectiveness. You write down the value added model, and you write down what would be the expected Y if that child had attended a charter school. And then you get so you have value added statistics. You actually know what the value added was for if you believe the experiment for the charter schools, and you can back out estimates of whether the value added statistics are accurate. We've got a paper. It's kind of complicated, and my mind is not exactly able to give you this, but it's very interesting, and that way you're beginning to get some kind of a picture of it, some kind of a picture of what might have happened in the car.
Yeah, yeah. Although the effectiveness of those other opportunities you get from that, but probably not what kind of service differential you got. So if you want to explain the mechanisms, you're not getting there. Yeah, yeah. Yeah, Howard's tried to do this a bit with the small schools of choice in some ways, of looking at is the reason that the effects are really big at these types of places because what they were being compared to in terms of its effectiveness potentially big or small, or is it because, is it like they're particularly effective schools, or is it that they're counterfactual is really ineffective schools is one way to say that, I think.
I guess the basic idea is that the value added is an estimate of how well this kid who went to a charter school would have done if this kid had gone to this other school. And since we have some estimate, enough such.
Yeah, no, it's a good point, though. All right. So yeah, you probably get the idea. Here's the plot of what it is for career academies. Again, probably that tau is really imprecisely estimated, but we think that these are like this is the best program ever, basically. Big positive effects and no variation. But there's only 9 sites, so when we add confidence intervals, this will be more interesting. But
You've had like the significant statistics in all the towns. So you have estimated the standard deviation of tau?
we've estimated the Q statistic, which then determines statistical significance. But because it's a standard deviation, it's not symmetric confidence intervals. So you can't just like take the standard error and yeah. All right, and here's the same kind of graph for WelfaretoWork. So again, this one, pretty good positive effects, a bit of variation. Doesn't look like there's a lot of negative effects, but there actually seem to be some sites where you kind of wish you'd lost the lottery. But mostly you're better off. All right, so discussion, which is what I actually prefer. Is there? No, okay. You sure? Yeah. Okay. All right, so 2 things I want to discuss. One is the implications for planning multi-site RCTs, which feeds directly into like what Howard was talking about with power. And then the next is some sort of nascent theory building about when it is we might expect a lot or a little of impact variation. So this is the formula that Howard showed us earlier, and I won't walk through it again in detail. But the main thing I want to point out is before those results that I just showed you, hopefully, when you were doing this, I don't know what you were supposed to plug in for tau. You just sort of had to make something up, I think. So we hope that having that list of estimates from existing past studies at least gives you some sort of empirical basis for what you might want to plug in when you're doing this. Ideally, you might be doing a study of a program that seems similar to one of those studies that I described. So maybe you choose the tau from that, or you might be in trouble if you're not doing a study that is similar to those, and then maybe you need some sort of theory, which is what I'll go into next, to sort of guess is it sort of big or small relative to what we've seen in the past, which is what I presented. So, but just to make, yeah.
So there's a lot of different estimates of tau in your table. So the tau of tau is really big, right?
The tau of tau. Oh yeah, how much it varies. Yeah. So what should I choose? Should I choose? I think it's the 0.81 or the 0.31. And that.
That adds a lot of uncertainty.
Yeah.
I don't know how much this narrows the uncertainty space, unless I know my interventional profile.
I think you're right. I think you're right, but you tell me if you think you're right.
So here's the way I would respond. So in the optimal design software, you can specify a range of tau and get power curves. And depending on other stuff, in some cases, it's pretty similar estimates of power over that range. So that, in other words, even though you might have a lot of uncertainty about that, you might discover that your planning of the study might not be consensus or might not. So I think, and I guess it depends on what else is in that formula.
Yeah.
How big, what value.
But also what might not go into it. Just trying to imagine under what conditions you would still modify impact variation and what conditions you would not. Thinking in those terms, knowing something about how those terms are reflected in those studies helps you just try to move forward.
Yeah.
Figure out where you might be in that thinking with the study you're trying to form. Not just the numbers, but some beginnings of a sense of why those numbers are different.
But I agree. I mean, I hope that we're better off now than not having any numbers. Damn, I hope it'd be very sad if we're not. But maybe. And then if I'm doing a study of an early childhood program that feels like Head Start, maybe I don't feel bad expecting a lot of impact variation. If I'm like super worried about being underpowered, maybe I just choose upper boundish tau estimates. I don't know. But it is hard to think about what do I do if I'm not doing a study that looks enough like any of these, and that's where I hope maybe this attempt at a theory would give you a better guess, but I don't know. Yeah. Although I have to say, I've used that analogy before, and I'm not certain how convinced I am, because with the ICCs, you eventually could get database, like I could get a whole states database and calculate it. But for this, you have to get treatment effects at sites. So I don't know if we're going to, as that's true. Yeah, so we only did 15. We should do the other 100. That should be the next project, do the other 160. Although not all of those are, like a lot of those are cluster random assignment, right? So then you can't get an estimate of this tau, how much the effects vary across schools. Or you might be able to get how much do they vary across districts. But sites as defined as schools? But I guess my point is this is a specific, how much does effects vary across sites as defined by schools. But you'll be, if you look at that, how much do effects vary across sites, so, sorry, in case this doesn't make sense, folks, we're talking about the fact that there's a lot of cluster randomized trials. And in those, they usually are multi-site. But by site there, they don't mean schools. They mean like usually districts. So they randomize schools within districts. So if you were to estimate how much do effects vary across those sites, what you'd be asking is a really different question than this here. You'd be asking how much do treatment effects vary across districts, not across schools, which is what we're almost always doing here. And you can imagine good, yeah. Yeah. And that would not, I guess that, it would inform this kind of power calculation. Yeah. Although it would inform if you wanted to use this kind of a model for a cluster randomized, multi-site cluster randomized trial, you probably really, if you're using a superpopulation framework, you could plug in an estimate of the cross-district distribution, so the cross-district standard deviation of treatment effects, right? I think that probably would be a power formula that one could use. Do you agree, or?
Well, I was just thinking of another thing. Probably another question. But what if you subdivided? Let's say, what if you subdivided your sample, the sample that you take into, SES by gender, by ethnicity, by language, whatever, and you had sites that were actually covariate classes, and you could start getting some sense of heterogeneity. At least then you're kind of probe on individual heterogeneity.
Yeah.
There might be other ways. It's a little different, but there are other ways to kind of
Yeah.
use the data more informatively to figure out something like that.
Yeah.
I agree. I just think it's good stuff.
Oh, good. We got approval over here. All right. Okay, we did all this. Okay, yeah. So here's just a couple examples of how this, would work if you're really planning a study. And I've just fixed some things. So I'm saying, let's say you know that the R squared is 0.50. You assume that we're using a standard effect size or a z-score kind of outcome. If you already know that your sites are going to have around 75 people each, and you're going to use a 0.5, half the people will be assigned to treatment, half control. What happens if you then say, what if I increase the number of sites? How will that change my minimum detectable effect? And I just used two possible taus just from two of the studies. So one where in the charter study where there's a decent amount of impact variation, 0.16, the after school was 0.04. And let's just say you have a discussion with policymakers and they understand effect sizes, so already this is probably not super realistic. But you say, I want to make sure I'm powered to detect an effect of 0.20. If you think you're sort of in the charter school situation, you only need 8, do I have this backwards? No, I have them, oh yeah, sorry. You need 13 sites. Whereas if you think you're in the after school, you only need 8 sites. So you can see what your estimate of tau is can make a pretty big difference. So I don't know if this makes you not happy about, yeah. Yeah, and you see, if you really wanted an even smaller minimum detectable effect size, you can see like the number of sites gets really big. And again, this is like all, at least to me, it's all about cost. Like you're always going to be like, oh, I wish I had 46 sites, but you're not going to get funding potentially to do the 46-site study. So it can matter a lot. you're like totally.
You'll get to a point where it makes an infinite amount.
Yeah, whereas if you think that your program's gonna have like the largest effects ever, you might be, it might not matter at all.
Sorry, can you remind me, these taus are the variances or the standard deviations of the treatment?
They are the standard deviation, the cross site. So each site has an average effect. It's the cross site standard deviation of treatment effects. Yeah, and I do that for the reason Howard said too. Like it's really hard to think in squared units. Yeah. But if you think sort of, I think a lot of education studies, oftentimes people want a minimum detectable effect. I don't know, but between 0.10 and 0.20 is considered, I think, probably reasonable. If you get above that, it seems less likely that you're going to have programs that actually have that big of an effect. So then if you think about how much of a standard deviation, so let's say your overall average treatment effect was 0.20, this would still have there be some, if there's with normal distribution, there'd still be some sites where there's negative effects and some with very positive effects. So that's one way of, I guess, thinking about what is considered a big or a small tau, is to think, well, how does this compare to what kind of effects we normally see and what that would imply for how wide the distribution would be?
So, I mean, how should we be then? Because I'm just thinking in a situation where you're trying to triangulate your tau based on some other research studies, but then you might be wrong. But then it's like you're trying to find an NDES of like 0.15, which is not unreasonable that you want.
So what do you do? What do you do?
Yeah, that like, estimate of tau might be really off, which might really kind of mess up your power.
Yeah, I mean, so again, I guess if you are like really, if you're kind of risk averse, maybe you just say, well, I'm going to assume the 0.16 and make sure I recruit more, and then you're going to have a really expensive study, and you try to convince a funder that it's worth it. That there's not perfect information about what tau is going to be. We don't really know. It seems like we've seen things in this range. I want to choose an upper value because I don't want to end up wasting your money by having an underpowered study, but I don't know in advance for sure what tau will be. It is tough though. Yeah, God, I wish we like knew taus across tons and tons of different studies, and that they were all more precise.
The other question is whether, we should look at this more and figure out if one of the taus is very substantial and the other one is basically zero, then it's going to make a huge difference. I mean, let's put it this way. If tau is zero, I can get by with one site.
One very big site.
Okay, so if I set one of my taus to be near zero, then I can get by with slightly more than one site. But if I make, so I think that your example in that sense, the 04, that's the square, the standard deviation square of that is 0.00, is, pretty small, probably by seems we get through the community. So I think that we should, that might be the one thing that is going to exaggerate a lot, is the smaller towers.
I mean, well, this will make them angry, but I'll just say it to this half of the room. The other thing you can do is not use a superpopulation model, and then all of a sudden tau is not in the equation anymore, and you're not trying to infer to a population of sites beyond where you are, and then all of a sudden, I don't know, you can detect smaller effects, everything's nice. So if you're writing the proposal, you might just try to argue for not using a superpopulation model, and then you'll feel better. But
You'll at least be funded.
you might get funded. Yeah. You'll end up with smaller standard errors. Everyone will be happy, but then people will use your results to make generalizations that they're not very well grounded. But all right. So trying to bring this back to the beginning, which is, again, is going to be about when we might expect effects to vary a lot or little. So this is probably like a bias that I think Howard and I share, and I don't know if others will agree or not. But we tend to think, maybe I shouldn't give you too much, I shouldn't attribute it to you. But if you read that paper that we wrote, we talked a lot about the treatment contrast, which is the differences in the services that you experience if you're in the treatment group versus what you would have experienced if you're in the control group. Those sort of lead to outcomes. If you had no difference between those, you'd expect no treatment effect. But I'd say like the main theory we have as now is that if I'm trying to anticipate how much treatment effect heterogeneity to expect, in terms of heterogeneity of treatment effects on the outcome of interest, a place to look is heterogeneity of the treatment contrast. So not the outcomes, but variation across sites in the services and activities that you get if you're in the treatment group or the control group. So when we think that the site average treatment contrast differences in services activities will be great, then I think we think there'll be a lot of heterogeneity. in-treatment effects on the outcomes of interest. So just to add some more fun notation and try to talk in more detail about how I might anticipate when to expect a lot of treatment contrast variation across sites. So the treatment contrast, you can write it at site J. The average treatment contrast at site J is equal to, just by definition, the services that people get on average if they're at site J when they're assigned to the treatment minus the services they get when they're assigned to the control at site J. And so our hypothesis is that the variance, as the variance of TC increases, so will tau. Another way to write that, just using sort of basic stats, is that the variance of the treatment contrast is the variance of the services across sites when you're assigned to the treatment group, plus the variance in the services that you get on average across sites if you're in the control, plus 2 times the covariance between those two things. I'm going to go into that in a tiny bit more detail on the next slide. Minus? Should that be minus? Minus, sorry. Okay. I wrote it right, but I said it wrong. Okay, good. Okay. So let's just go through these to make them make sense, and then you'll see, I think, how I can imagine potentially predicting when I might expect a large variance in the treatment contrast. We're going to go term by term to help understand when you might expect a large variance in the treatment contrast, which in turn might mean you expect a larger tau. Maybe. And I should say, the stuff that I'm talking about now is very speculative. Some of it is based on theories that Howard and I mostly had before looking at the sort of estimates of tau, some of which we sort of developed by looking at the results. So it's totally speculative. Don't take this to be truth in any way. So variance in the services that you experience when you're part of the treatment. So this is an example where there's large variation in program services. Let's just imagine that our intervention is something very simple. It's like going to more advising sessions. So I do work in community colleges. People don't get enough advising. They think that if you had more, you'd do better on outcomes. So imagine on the x-axis, you've got 5 different sites, A through F, and maybe the y-axis is the number of visits to an advisor you have. And so this is an example where there's a lot of variation if you're in the program group between the number of advising visits that you get. It results in a large variation in the treatment contrast. That's the numbers above, the differences between program and control. And so that's what that's supposed to mean. Here, almost no variation in the program group services on average that you get across sites, and very little variation in the treatment contrast. So an example of when I can imagine that might be the case is if you have a program model that has low specificity, you might be over here. So for example, in the charter study, is that the one I wanted to use? Let me make sure I use the examples that I cherry-picked in advance. Yeah, charters is a good one. So in charters, you might be here because remember, it wasn't like they were all KIPP charters where they've got a specific program model, everyone's supposed to get the same curriculum, the same pedagogical approaches. It was a whole bunch of different charter schools. So the services that the charters offer, you just would expect lots of variation across them because they have totally different models, designs, plans, whatever. So that's an example. In contrast to the Success for All after-school program, this highly prescribed program where you'd think the variation across sites in the services that were offered would probably be much smaller because they have a central provider that has a very fixed set of curriculum. There's like a coaching that they actually do to train the teachers, so they're all supposed to be on the sort of same page. So you might expect lower variation there, and therefore maybe lower treatment contrast. So that's maybe one hypothesis as to when you'd expect this one part that contributes to the treatment contrast to be small or large. Okay. Variance in the counterfactual services. I actually think this is probably where a lot of the action is, but I also think that it's almost always going to be the case that this will be large. And the reason why is actually very similar to when I expect a lot of variation in the treatment across sites to be large. So when there's low specificity in the treatment, I expect a lot of variation in what's experienced by treatment group members to be, we expect it to be large across sites. The control, almost always in a multi-site trial, if you're in the control group across sites, there's no reason to think that they're going to sort of have some shared set of services or experiences that they offer. So I think that this is just always going to be large. It's hard to imagine a situation where it's not, unless all of your sites were selected because they're already operating the same kind of program and you're testing it like an add-on program. Then maybe in the control group you end up getting similar-ish services across sites. But if not, it just seems like these sites are they're different schools, they're different welfare centers, they're doing their own thing. There is no central organization. I just think you're going to see a lot of variation in the services that are offered from the control group. So last but not least, the covariance. And I'll try to go through this one quickly. We have graphs here as to what this might look like. Here, there's very little covariance and a lot of variation. Here, despite the fact that the program services vary a lot, that's the blue bars, and the control services vary a lot, they covary perfectly, and so there's actually no variation in the treatment contrast. That's sort of like the idea. That then you have very little treatment contrast and then maybe very little variation in treatment effects. So a couple of situations where we think that this covariance might be big or small. One is about the proportion of your formal education that is altered by the intervention. So in an example, in the after-school programs, during the entire regular part of the school day, whether or not you were in the treatment group or the control group, you were getting the same stuff. You were in the same schools. So they sort of perfectly covary if it's the math after-school program. During the school day, the program and control were in the same math classes, so their experiences perfectly covary. It's only in the 45-minute period after school that there's any chance that things are actually going to be different between program and control within site. And so you might expect then there's going to be a pretty big covariance there because of the fact that all day long, within site, people are getting basically the same experiences if they're in program or control during the day. It's only at the end of the day. And in contrast, take like a small schools of choice type of example. In that case, if you're in the program group, you go into a small school. If you're in the control, you get scattered about to all these other places. There's not a good reason to think necessarily that those services and experiences that you get are going to perfectly covary across the small schools that you applied to. It's hard for me to know why that would necessarily happen. Not that it's not possible, but it's just not as clear as in the after-school case as to why it will be the case that they'll have lots of similar experiences if you're at the same site during the day. And then kind of similarly, I think just in general, if your treatment and control group members from the same site are served in different locations, then I think you're going to expect you're going to expect more variation in the treatment contrast because of the fact that you'll have a smaller covariance. So in this case, it's just in general, I think that if your control group goes elsewhere, they're going to have it's less likely that the services and experiences that they have will happen to perfectly covary with what they would have had if they're in the program group. I don't know. Do people have questions or comments on this? Or are we all just getting tired now? All right. 2 more slides and then I'm done. Because I feel like I'm losing you. So what about the client characteristics? So if you remember in the beginning, I said there's 3 sources of variation that we focus on. 1 is treatment contrast, 2 is client characteristics, and 3 is context. I think that it's possible that treatment effects vary a lot across sites because of client characteristics, but I think it's going to be hard to predict. And so I don't know that if you're trying to guess your tau, that this is the place to look. And there's 2 reasons why. One is for a lot of characteristics, and especially ones that are commonly used as moderators, most of the variation is actually within sites. So for example, if you look at estimates of the interclass correlation, which is a measure of how much variability in outcomes is across sites versus within sites, it tends to be fairly small. It's like 0.15 or 0.20. So that suggests that most of the variation in outcomes, at least, occurs within sites, not between sites. And so if there isn't a lot of variation between sites then in characteristics, then it probably is the case that you can't see a lot of variation across sites and impacts because of this type of a moderator. That probably isn't true for all characteristics, so maybe like SES. Actually, Sean, you must know this, whether or not there's a greater ICC for things like SES. But I suspect that for a lot of variables, there's more variation within sites than between sites. Is that? Also, it's low. You know, the ICC is like in the 0.20 range. Or? But in general, that would be one reason why. So in order for there to be a lot of cross-site treatment effect heterogeneity caused by client characteristics, it has to be that there's a lot of variation between sites in that characteristic, and it is a moderator of treatment effect. And so then the second part of this is just that I think it's a hard thing to predict. And the reason I think it's a hard thing to predict is somebody here and I were talking earlier about like replication studies. And if you, at least from what I've read by David Yeager, who some of you know, and Beth Tipton, they looked at many replication studies that I forget who put together this big replication project, but there were 100 or so studies that were replications that they looked at, and they find that oftentimes effects aren't replicated. Then they looked at specifically those studies that try to replicate subgroup kind of findings versus those that look at main effects. And what they found was something like 40% of the time replication is quote unquote successful when it's the main effect. But when it was specifically client characteristics or subgroup findings, it was something like 1 in 27 times that they found successful replication, which suggests to me that a lot of the subgroup findings that we talk about, emphasize, may just be spurious. It might be that we're fishing a little too much. I don't know, but it suggests to me at least it's hard to really predict, given that we've been fairly unsuccessful replicating subgroup findings. So it just makes me think, in general, if I'm going to anticipate a large tau, I don't think it's going to be because I think that there's a lot of variation in client characteristics, and I know that the treatment effect is moderated by that characteristic, because so far we don't seem to be great at that I know of. Does anyone disagree? All right, last but not least, what about context? This one I'll just say quickly that I think there probably is a bunch of contextual moderation, but I think a lot of times it's going to occur through the treatment contrast. So a lot of times when you hear examples of the possibility of contextual moderation, it's things like, I think this treatment is going to work well in a service-rich environment versus in a service-poor, or sorry, in a service-poor environment, this treatment will work well versus in a service-rich environment. And I think what you're really saying there is the control experiences, in other words, part of the treatment contrast, is going to be really different, and that's what's going to be the source of impact variation. So I almost feel like this gets taken care of through the treatment contrast a lot of the time. But that's our